Hello everyone. Today we discuss about the topic serverless, the future or is just hype. In this topic we discuss the serverless computing, future scopes and what is why this is called a hype. Well, let's start the topic with introduction. First, we need to know about the serverless computing. It is nothing but is cloud computing model where developers write the code, deploy code without need and to manage the underlying infrastructure. In this model, it's used cloud storage. In the key feature of it is function as a services FAS, where the common implementation are broken down into individual functions that execute in responsible to event. And second one is event-driven architecture, where functions are triggered by events such as HTTP request. And next is automatic scaling. Serverless platform scaling automatically based on demand. If more traffic come in the cloud provide accumulate more resources. Here we can see the serverless architecture to how it's work. Next we discuss the why it is the topic important now. The topic serverless computing is growing rapidly due to several factors. First is cost efficiency. Traditional cloud computing often involve paying to resolve resources. Second is faster time to market. Serverless allows deployer to quick deploy code without worrying about infrastructure, resulting in the fast product in iteration and updates. Second, third one is cloud negative development. As organization increasingly shift to cloud shift strategies, serverless computing, file assembly into cloud native architectures. And fourth, microservice and event architectures, where serverless work well are for microservices application where the logics is divided into independently deployed functions. Fifth, scalability and availability. The auto scaling and a high availability feature provided by serverless platforms. Next, we discuss the traditional versus serverless architectures, where we see the some pictures about the cost and its architecture flow or cost or scale for traditional and serverless architecture. Then how we can understand it more efficient like for traditional architecture. Next, we discuss how it's work. It's work on the two basic concepts. First, event-driven architecture, where the applications are triggered by events. Their events can be anything from an HTTP request, upload to cloud storage, changes in a database, or a scheduled task. The key elements of event-driven architecture is event resources. They are user requests, systems alerts to trigger that initial and actions, and events handlers function, that is serverless function that provide the events when the event occurs. And second one is last one in the no server management. The cloud provide and necessary resources to handle the events. Here we can see the event driven architecture where we can see how the this architecture workflow and understand the basic about it working. And next we discuss the function as a services FAAS. In this model in serverless computing, it allow to you deploy individual functions that execute in responsive to events. With FAAS, you write the logics for each function. And what is the key feature of FAS is stateless function, which is independent, meaning it does not retain any memory between executions. And scalability function automatically scale based on demand. And short execution function typically have a short execution time from millions seconds to minute, making them and pay per execution, only pay for the time the function run, not ideal server time. And we see the architecture of FAS, where a web app or API gateway and the user extend APIs and database are connected each other and its functionalities how it works. Next, the key feature of serverless architecture is No server management in this benefit is the developers on focus on entire on writing code and building features rather than the managing infrastructure and automatic stability where server automatic scale resources. The benefit of this is no need any worry about providing enough server on scaling manually and building in security to benefit to develop no need any manually configured security for infrastructure that lead enhanced security for applications. High ability and fault tolerance. The benefit of reliability and uptime for application without required deploy to manage complex mechanism or revolutions and simplify deployment. A streamlined deployment process means that the developers can push new features and updates quickly without complex building pipelines and infrastructure configurations. Next, we discuss the use cases where we can use it. Where for a real-time file or image processing, can use photo sharing apps, document management, where we use serverless architecture without any problem. And second one is RESTful APIs or backend code for web apps and mobile backends, e-commerce platforms. Schedule tasks, cron jobs like use for maintaining scripts and automatic workflows. Use also in chatbots and assistant like customer support chatbots and Slack bots and Alexa skills. And or more use cases are in IoT. We use it like for smart home system and agriculture sensors, industrial monitoring, and real-time notifications where we use it in like user alerts and order updates and data transfer pipelines to use analytic dashboards or log pressing financial reportings and machine learning interface also for smart research and fraud detection and personalization systems. Next, we discuss the real-world examples for service architecture is Netflix, where Netflix use it in real-time video coding, log analysis, and monitoring. For its benefit is reduced latency and improved scalability without overprovisioning infrastructure. And second one is Coca-Cola, where we see the welding machines where we use welding machines which lower infrastructure cost and easy to scalability, especially during promotion and seasonal spikes. And the Asia's e-commerce platforms Zovalero use case real-time inventory update and promotion where we benefit is improve customer experience and scalable to easily during flash scales. And Autodesk we also use in Autodesk to reduce overhead and support elastic scaling. And I use on also using iRobots for real-time scalable data processing without needing a large backend. And to now discuss the challenge and limitation of serverless computing. First is cold start, where this function has not been used recently. Its cloud provide may take extra time, hundred of millions second to 1 second, in a moment. And second one is limited execution time. Most serverless platform enforce the limited on how long a function can run. And third one is debugging and monitoring complexity, where the function run in imperial content managed by the provider traditionally. The debugging method are not don't apply. Fourth one is limited language environment support, where not programmable libraries are supported to the box. Then the impact of this may require workaround the configurative deployment for customer environment. And other challenges on we face the security concerns where serverless function may many small rapid deployed entry points that can be exploited if not properly secured. And state management where the serverless functions are stateless by default, meaning they don't retain inform between invocation. And seventh one is concurrency limited and throttling, where provider sets limits and how may function intents can run in parallel. So request higher limited SQL access events like using SQS and pub and sub. Cost estimate challenge where serverless is cost effective for low usage. A cost can be spiked unpredictably with high traffic. It's a very important point. And when to not use or unuse serverless system, where we use some points, we use of serverless when and avoid the serverless when. At some points are given key when we schedule an event-driven flow, you want fast deployment, pay to use only, uses only, and orchestrate cleanliness, and you manage service like APIs and DBs, etc. And the win avoid when we constant heavy workload, fine-grained infrastructure control, and running long and present background. And we need a presence session and shared memory where we avoid. And it's the future scope is short answer is yes, but construct. Serverless computing powerful trend, but they're replacing how applications are built and deployed. It will not replace traditional architecture, it's consist and dominate its performance or growth application. The serverless computing market is experiencing a substantial growth, but the projection indication is strong upward. Or the key benefits of it is increased deployment productivity by abstracting away infrastructure management and expanding use cases for data processing, event architecture, and AI and ML workload, and even edge computing. And also the cloud computing, it's aligned to growing evolution of cloud computing, allowing developers to business logics and rather than service administration. Here we discuss about the Now we discuss the conclusion points for serverless architecture. Its developers can focus on code and automatically handle scaling based demands, and it's pay for only for when we it use and backend by major cloud provider and growing in popularity across industries and not with challenges like cold start, vendor lock, and debug complexity. On future lies in hybrid models for base result often for combined serverless with traditional containers. Thank you very much guys, and I hope you like these videos. Thank you.